This is a lesson on student learning task 4, determining algebraic inverses. We're going to continue our investigation of inverse functions and start by graphically determining 3 inverses. So what I'd like you to do is write down these 3 functions, graph them either by hand or by calculator, and then create a paper graph. And then use the ordered pairs from your original graph to find the inverse. So go ahead and pause the video. Okay, just as a tip, if you need to, you just type it into y equals, go to your table, go to graph. All right, so I've done that, and here's what my graphs look like. So I'm going to take the first graph, has a point of 2, 1/2. If I take 2, 1/2 and reflect it over the line y equals x, I get 1/2, 2, and I find that that's on the original graph. Then if I take, like, let's say 3, 1/3 and reflect it, it's also here. Over here, if I take 2, 1 and reflect it, I find 1, 2. And I find this phenomenon is happening over and over. Like if I take the point 1, -1 and reflect it, there it is. So what happens is that the graph, even when it's reflected, you kind of can see this if you can imagine folding these graphs in half. Specifically with number 3, this piece would line up perfectly. And what we find is that the inverse of this type of function, so what is this function called? 1 over x. This is called the reciprocal function. The inverse of the reciprocal function is the reciprocal function. Because f of x equals 1 over x is symmetrical around y equals x. Okay, now if we transform this reciprocal function, it may or may not be true that it's its own inverse. In these 3 situations, the parent function, a dilation, and a reflection over the x-axis, it turns out that it is true that they are their own inverses. So that's a neat little phenomenon. So I want you to go ahead and turn in your packet to page 17. We're going to get into the meat of this lesson. It's called pulling a rabbit out of a hat. And it's not really a magic trick, but it's kind of like a magic trick. So this is what I would like you to do. Pick a number, any number. Pick your favorite number. Now take your number and add 6 to it. So I'm just going to demonstrate. My number is going to be 24 because I like the number 24. If I add 6 to it, I get 30. You do the same thing with your number. If I multiply the result by 2, I get 60. Subtract 12, I get 48. Divide it by 2, and I'm back where I started with. This is not a magic trick, okay? This is simply that we have a function, and then we have its inverse function. So consider the example at the bottom. If the number I had picked was 7, and my function was x plus 8, well, obviously that would give me 18. Then, if I subtract 8, it will take me back to 7, because subtracting 8 is the undoing step, the inverse of adding 8. So go ahead and take a look at page 18. So number 1, we have x equals 7, and the operation here is to multiply by 3. So the inverse function will be to take x and divide by 3. Okay, not so bad. Here for number 2, I'm squaring. Okay, so what's the opposite of squaring? What undoes a square? A square root. So square root the 49. They are inverse functions, squaring and square rooting, multiplying and dividing. All right. So now in number 3, we've gotten a little more complicated because we have 2x minus 5. So how are we going to approach this? So we need to think about, when I follow PEMDAS here, what happens first. And the first thing that I'm doing is I'm multiplying by 2. So what I like to do is lay out arrows. I'm going from x, and I'm going to multiply by 2, and that gives me 2x. So that gave me like a 14 here. Then I subtract the 5, and I get 9. So if I want to get the original output is 7, I need to do the opposite operations in reverse order, and that's going to be how I obtain my inverse function. So opposite operations in reverse order, well, the opposite of subtracting 5 would obviously be to add 5. So add 5, and then the opposite of multiplying by 2 would be to divide by 2. Oh no, the purple pen is dying. I'll have to use blue. Alright, so that leaves my final function. If I'm adding 5, so I'm going to go x plus 5 over 2. Let's see if that works out. So if I take 9 plus 5 is 14, divided by 2 is 7. Check. Alright, so what I want you to do is I want you to think about how I would lay out the arrows for number 4. Alright, so what are we going to do first for number 4? We are going to add 5. So we're going from x to x plus 5. Add 5. Then we're going to divide by 3. X plus 5 over 3. So in words, to undo this function, first, what's the opposite of dividing by 3? That would be multiplying by 3. And then the opposite of adding 5 would be to subtract 5. So first multiply by 3 would be 3x. Then subtract 5 would be minus 5. I don't know why I wrote that small. I could have just written it like 3x minus 5. Oh well. All right, I want you to try number 5 on your own. See if you can come up with the steps to undo f of x. Pause the video. Okay, hopefully the first thing you did was you took f of x and you said, all right, well, the first thing that's happening to x is we are subtracting 3. And then the next thing that's happening to x is we are squaring. I like to write the words like SQ because if I just put a little 2 there, sometimes I don't always know what I'm doing with the 2. What is the opposite? How do I undo a square? With a square root. Then add 3. So first I'm going to take the square root of x, and then I'm going to add 3. And I want you to notice that I was very specific to make sure that there was like a little bit of space, because I don't want to look like I don't want it to look like the plus 3 is underneath the square root. That would be just a tragedy of extremely epic proportions. So there is one more on page 20. So take a look at number 6. All right, so when we look at number 6, this function, the way it's written, what is the first thing that's happening? Well, hopefully the first thing you said is happening is that we are taking the square root of x. And then it's like you're taking 4 and you're subtracting that result, and that's not really an operation. So my suggestion to you is that you rewrite, whenever you have 4, like a number minus and then the x, write it like this, like write it like f of x equals negative root x plus 4, or even better, f of x equals negative 1 times root x plus 4. And I will give you a hint. This function has 3 steps in it, so it will take 3 steps to undo it. Go ahead and lay out 3 arrows to build the function, and then think about how you would undo the function. Hopefully the first thing you did with the x was you took the square root. And then, and this is like the tricky step, you multiplied by -1 to get negative root x. And then the last thing you did, you actually added 4 to get negative root x plus 4. So, to undo this, the first thing we're going to have to do is subtract 4. Then, what's the opposite of multiplication? We're going to divide by -1. Now, sidebar. Because this is -1 we're talking about, multiplying by -1 and dividing by -1, those are really the same thing, but that's only true for 1 and -1, so don't get too excited that they're the same. And then our last thing, the opposite of a square root, is to square everything. So let's see if we can build a function with these steps. So I'm going to take my x. Actually, I'm going to do this on a bigger piece of paper. Cut it as a really small box, then we'll write our result. So we have x, and then we're going to subtract 4. Okay, then we're going to multiply it by -1. So I don't want to do this because this is like really ugly. I'm going to instead say, okay, that's going to be, I mean, you could also do it like this, like, that's kind of ugly too. I'm going to make it -x plus 4 because like if I distributed, all right, so then the last is to square, so then I get my final f inverse of x is -x plus 4 squared. And if you were so inclined, because you're feeling a little fancy, you could write it like that also. So subtract 4, multiply by -1, again, whichever you prefer. I distributed. You could, in theory, just kind of leave this hot mess with the squared outside, but I can't because the ugliness is just hurting my eyes. There we go. All right. So each of these problems began with x equals 7. What is the difference between the x used in f of x and the x used in f inverse? So for that, I'm going to return your attention because we really did this a lot, I think, in which one did we do? Oh, number 3. So when we plugged in to the function, we actually plugged in 9, right? So here, the x we were using wasn't 7, but 9. Where did the 9 come from? The x used in f inverse of x was the output of the function f of x. So like whatever came out of f of x is what we put in, was the input value for the inverse function. So in number 4, could any value of x been used and still have the same output from the inverse? And the answer to that, of course, is yes. Any value can be used because if you look at number 4, what kind of function is that? Or I just missed the in because it was a linear function. We make a line. Okay. This would not be true for all functions. Like I can't use any function, like any number, and get the same result for quadratics and things with restricted domains. And that's something we'll look at in the next few days as we continue our explorations on inverse functions. So number 9 says, based on your work in this task and other tasks in the module, what relationships do you see between functions and their inverses? And this is like the big finale here. So our big finale should be something like the inverse function will undo the original function and return an output identical, don't know how to spell identical. I feel like that's wrong, but I'm gonna go with it. To the original input. Boop. All right, I'm gonna make a little note here. If you did not get this, is the big, their final deep thought. To find an inverse function, we do the opposite steps backwards. Hooray! All right, ladies and gentlemen, your homework tonight is page 21, which woo, earthquake, not really. I just hit the thing. I do not have the, oh yes I do! Here it is, yay! Here's page 21, ta-da! You are to complete numbers 1, 2, 3, ding, and also 13. So we're not doing this middle part yet, not yet, guys. And then, let's see, 1, 2, 3, and 13 to 24, and I'm just gonna give you a little hint. Map out the function. And you can pause the video here at the end. I'll put the answers on so that you can see what the answers are and check as you go.